So our so what we do, I think gear up a little bit of notation. I'm going to keep the notation at a minimum to describe our thing. So you have an experiment. You have n units and r treatment categories. And r is 2 or greater. Doesn't matter how many treatment categories you have. Doesn't matter how much n you have. Right? And then you have to pick a threshold. Call it T star. And what T star is, it says I want this at least this many observations in a block. Right? And T star obviously has to be at least equal to R, the number of treatments you have. But you could say I want it to be twice the number of treatments, 3 times the number of treatments, or just equal to the number of treatments. Doesn't matter. The algorithm will just do what it's going to do. Right? Now what the algorithm's going to do is going to give you in every block at least T star number. But some blocks might be larger than T star. But why is that? And there's going to be a good reason for it, which I'll describe. Because in many cases, you might not minimize the maximum intra-block distance if you only have T-star. I.e., if you ask for pair matching to our algorithm, it might not give you pair matching. It might decide actually some of those pairs should actually have 3 observations. And I'll give you an example for why. Because if you didn't, it wouldn't be minimizing the maximum intra-block distance. It might actually make covariate distance worse. It sounds weird. It sounds like, hey, if I paired match, that must be the minimum, that must be the best way to get the covariance to be as close as possible. But that's actually not true. Right? And so here's going to be the running example. So the running example is simple. It's weights and heights. It has 12 observations. The example is obviously constructed in a way that you should be able to eyeball and say, hey, I know that should have 4 clusters. And you're going to ask the algorithm, I want to give treatment and control, I want at least 2 units in every cluster, right, in every block. And that's what it's going to do. And you have to pick a distance measure. We're going to pick Helmholtz distance. We don't know what that is. Don't worry about it. You can just think about it as Euclidean distance, like the usual, you know, high school geometry distance measure. It's not the same as Helmholtz distance, but it will work for our thing as well. So if you pair match, this is how it would go. Right? Those would be the matches. And you can tell that 2 of those matches are pretty bad. Right? That's probably not, I mean, that's actually a lot of distance between this one and this one. Right? That's what pair matching would give you. No matter how you do the pair matching, you're going to get some issue. Right? Because the data's been designed to generate an issue. Right? This is going to be the result for the minimized maximum distance. So the key thing to note is you ask the algorithm only create blocks with at least 2 observations. It's going to look at the data and decide the way to minimize the maximum distance in all the blocks, right, is actually to give you block sizes of 3. And that is going to give you, and if this covariance predictive outcome, notwithstanding the theoretical result that asymptotically paired matching gives you the lowest mean squared error. In this data, in any data that looks like this, that's going to give you better efficiency than that. So the other thing to note is those theoretical results I was talking about, they're all like asymptotic, so this kind of problem goes away. Right? So they assume that as data becomes infinite, these distances get packed. So these problems don't occur. But in a finite set level, we're doing this because we don't have 50 million observations. Right? So you get this real disjuncture between the way we write the theoretical results and the real reason we're doing this is you know, we have an n of 40, we have an n of 100, and we want to maximize power. So these kinds of issues matter a lot. And in this case, if these covariates were predictive, you want that, not that, even if you started off saying I want paired matching. Right? So how does it do that? How does it decide that? Right? So first thing to note is what it's trying to minimize is the maximum intra-block distance, which in this case is those 2. And in our case, it's going to be that edge and that